Chemistry on Podcast.
Hi. All right. So what we're going to do now is we're going to talk about chemical equations again, chemical reactions, but they're in this thing called an aqueous solution. Aqueous. What substance do you think of when you look at aqueous?
Water.
Water. So these are all going to be happening when we do the chemical reactions in water. Okay? That's what aqueous means. So let's give some examples of this. Okay. When a salt is dissolved in water, it dissociates or breaks apart into its ions. Okay, remember when we talked about how salts or ionic compounds are electrolytes and how they conduct electricity when they're in solution? That's because they break apart into these ions. Okay, the example I have up there is sodium chloride. When I take sodium chloride and dissolve it in water, make a solution out of it, it becomes sodium plus and Cl minus. See that? So now let's do this other example here of calcium hydroxide. First of all, is it a salt? Is calcium hydroxide a salt?
Yes.
Yes, because it's got a metal and a polyatomic ion in it. Okay, so let's break this apart. What is the charge on calcium since it's in group 2?
+2.
+2. So I'm going to write +2 here. And what's the charge on hydroxide? It's a polyatomic ion. Find it on the sheet. -1, right? Would you agree?
Yeah.
So when this breaks apart, it's going to break apart into those ions. So the calcium is going to be like this, Ca2+, right? And the hydroxide is OH, and it's got a minus. Now, how many hydroxides are in calcium hydroxide?
2.
2. So I'm going to throw a 2 in front of that. So calcium hydroxide will break apart into Ca2+ and 2 OH minuses.
Cool.
Will it conduct electricity if I put it in water?
Yes.
It will, because it broke apart into ions. Now, there's other things out there like molecules. Remember we did in Chapter 8, all the things we drew, all those molecules? When they go into water, they don't dissociate at all. All right? And you'll notice when we mention these things, we have a little AQ there. That means aqueous. All right? So this would actually be aqueous as well. And this would be aqueous as well. Boom. It's a beautiful
Q. That looks like a G.
Oh, it's a Q, sister.
That's an O.
I don't think so. It's beautiful. Okay, so let's see. Would this dissociate in water? K, F.
E.
Would that dissociate in water? Is that a metal with a non-metal? Is potassium a metal?
Yeah.
Let's see. It's in group 1, right?
Yeah.
There it is. Is that a metal? Is F a non-metal?
Yes.
So that's a salt. Would it dissociate in water? Yes. How about this one?
Kentucky Fried Chicken actually will dissociate in water.
How about that one right there? N2O5.
Nitrate?
Nope. That's
Nitrogen.
dinitrogen pentoxide. Now.
That's a 5?
That's a 5.
Okay.
So, is that a metal and a non-metal? Is nitrogen a metal?
Yeah, no.
No. Is oxygen a metal?
No.
So, is this a salt?
No.
Would it dissociate in water?
No.
No, it would not. So, only your salts dissociate in water. Okay? Let's go on. All right, there are 3 situations we're going to look for here when we do reactions in solution. The first one's when a precipitate is formed. Do you know what a precipitate is?
A solid?
It's like when a solid forms. Okay, so what we're going to do is we're going to see how these solids form. So I'm going to do this. You see this reaction? See how it looks like a wife swap? There's a couple plus a couple. And what's going to happen is the silver and the sodium are going to change places.
How come the nitrate and the chlorine won't switch?
Well, you can pretend like they switch too. Either way.
Well, what if
But the silver's going to be with the chlorine after we're done, and the sodium's going to be with the nitrate after we're done.
Was it possible for the sodium and the silver to be together?
That is an awesome question. It is not. You know why? Because silver forms a positive ion, and sodium forms a positive ion. Is there any chance that we could possibly ever get a neutral compound when we put 2 positives together? That is a great point to make, though. Thank you for bringing that up. Okay. So here we go. So over here. So we got sodium. So the sodium was with the chlorine as a reactant. What's it going to be with as a product?
Nitrate.
Nitrate. So we're going to do NO3. We have to make sure it's a neutral compound. Sodium's a +1. Nitrate's a -1. Is it neutral?
Yeah.
Yep. Okay. So we're good there. And then the silver was with the nitrate before. What's it going to be with now?
The chlorine.
Chlorine. And we'll put a Cl there. The silver is a +1. The chlorine is a -1. Is it neutral? Yes. So we're good there. And it is balanced. Now, we need to determine whether these 2 things are soluble or not. Soluble is a big word, right?
Yeah.
Okay, so let's talk about what soluble means. If I take sugar and put it into water and stir it up,
It
will
dissolves.
it will dissolve. That's soluble. What if I take table salt and put it into water and stir it up? Will it dissolve? Yes, it will. So the salt will dissolve and sugar will dissolve. They're both soluble. Okay? What if I took chalk and put it into water and stirred it up? Would it dissolve?
Chalk dust or like a thing of chalk?
Chalk dust or a thing of chalk.
No.
It won't dissolve. That is insoluble. Okay? So if I take this...
Non-dissolvable.
Non-dissolvable. So if I take sodium nitrate and put it into water, based on the rules on the back of our cheat sheet, which we'll go over in class, you'll find out that it's soluble. See them right here? Okay? You don't need to know those rules for right now. Okay? So I look it up on the cheat sheet and I find out that this is soluble, so it will go in solution. So I write AQ, it's soluble. And the silver chloride will not dissolve in water, so it is insoluble. So what do you think it'll stay as?
Solid.
Solid. So we say solid right there. Boom.
But you're describing silver and chlorine as chalk.
Right, but it's not really. But it has the same physical property. It's
Got it.
insoluble. The next one is when water is formed. Okay, we have another type of reaction here. This is a double replacement again, wife swap. Okay, and we have HBr and NaOH. This is a very specific type where we have an acid, because it starts with an H, and it's reacting with a base, which ends in OH. So let's get rid of the sodium first. You ready? Sodium was with hydroxide before. What's it going to be with now?
Bromine.
Bromine. There we go. Let's make sure it's neutral. Sodium's a +1. Bromine's a -1. Is it neutral? Yep. And then the other things it forms is the H is going to go with the OH now, right? Which will look like this. HOH. But I'm going to rewrite it. What would you write that as?
H2O.
H2O. There we go. Boom. And this is a +1 and a -2. Hydrogen's a +1. Oxygen's a -2. Do we need two hydrogens? Then it's neutral. So instead of writing this, we just write H2O. So water was formed. So this right here is sodium bromide. It's like a salt, and it is able to be dissolved in water. If I took it in water, it was soluble, so I would write AQ. And water, which is actually, you can't dissolve water into water, is it? It's a pure substance, so we actually say a liquid. So
what is that?
That's an L.
No, it's not.
It's a cursive L.
That's like...
That's getting much worse.
breast cancer.
It's an L. The next one is when gas is formed. You ready? Okay. So we got two HIs. I don't know. I already started balancing, I guess. Li2S. And what's going to happen? Another wife swap deal. Let's go with the lithium first. What's the lithium going to go with?
Iodine.
Iodine. So I'm going to go Lii. Lithium is a +1. Iodine's a -1. Is it neutral? Yep. And the H and the S are going to go together. The H goes first because it's the positive one. It's a +1. And the S goes next, and it's a -2. Uh-oh.
It is. So you got to put your little like 2 thing that you already did.
Right there?
Mm-hmm.
Okay. So I have that 2 right there. Now this is aqueous. It's able to be dissolved in water, and my students will know how to do that, predict it. And this is dihydrogen sulfide gas.
Is that a G?
That's a G.
Just to reassure.
Yes, that's a gas. That is the stuff that smells like rotten egg farts.
What?
That's right.
I don't smell farts.
You've never smelled a rotten egg fart.
What does a rotten egg smell like?
What are you? Are you an alien? You have to know what a rotten egg fart smells like. They kind of smell like horrible.
We wear perfume as girls.
No, I didn't say you farted. I said if you smelled like a guy farted or a dog farts, it smells like rotten eggs. All right, so here's the hardest part of the chapter. I know you're excited for it. Okay, it's not that hard. It's just a lot of work. Okay, we're going to talk about these things called spectator ions, but we'll leave it for last. Okay, what we're going to do is anything that you see that is aqueous here is going to dissociate into its ions like we've been doing the whole time. Okay, so what I'm going to do first is I'm going to balance this equation. And I'll do it very quickly because we're experts at this now. So we got 2 chlorines over here. I put a 2 in front of that to give me 2 chlorines over here. That gives me 2 sodiums. Oh, I already got 2 sodiums. So we're good. Okay, we got 1 carbon on each side, 3 oxygens on each side. Everything's good. Okay, you ready? Yeah. Na2CO3, is that going to dissociate?
What is that?
Sodium carbonate. Is it a metal and a non-metal? Is there a polyatomic ion in it? Yes, so it's going to dissociate. All right. How many sodiums are in there?
2.
2. And sodiums always have what charge?
+1.
+1. So I get 2 Na positive ones. How many CO3s do I have in there?
3.
No.
1.
1. CO3. What is its charge?
I'm going to guess a negative.
Negatives. Negative something.
2.
-2. So I'm going to write 2 negative here. Okay, so we took care of Na2CO3, right? Let's do CaCl2. It's going to dissociate into calcium and chlorine, right?
Yep.
So calcium has a charge of what?
+1.
Plus
2.
2. And chlorine has a charge of?
-1.
-1. But we have 2 of them, right?
Yep.
So I'm going to go ahead and say we're going to dissociate into Ca2 plus. And how many chlorines?
2.
2. Cl, and what's its charge?
-1.
-1. There we go. So we dissociate both our salts when we put them in water, right?
Yep.
Okay, so now we've got this. Boom. And sodium chloride is also aqueous, so it's going to dissociate. How many sodiums do we have?
2.
2. 2 Na pluses. See how the Na had a +1?
Mm-hmm.
And how many chlorines?
1.
Ah,
2.
there we go. Toop. I don't know what that is. 2 Cl minuses there. And we now have this calcium carbonate. But look at this guy. It's a solid. See that? So guess what? It is not going to dissociate. Solids don't dissociate.
Just
only
leave it
aqueous
alone?
ones. We just leave it alone. We write it down as
Caco.
CaCO3.
Caco.
There you go.
Cubed.
I'm going to go ahead and throw a solid here. Somehow. There we go.
That
Now-
looks like a bunny.
I'm sorry. Now, all of these ions that have dissociated are aqueous, but I don't feel like writing aqueous for all of them. But let's know that. Anything that dissociated here was aqueous. Remember how these were aqueous?
Huh?
So these are aqueous. Over here on the left side,
Oh my god.
all the way over here on the left side, there's all these ions floating around. Okay, and they're all floating around. And they will come together in the most stable configuration. And that most stable configuration they have are these guys right here. Do you see, over on the left side, do you see a 2 Na plus?
Yes.
On the right side, do you see a 2 Na plus?
Yes.
So did Na plus do anything in this chemical reaction?
No.
Nothing.
Couch potato.
That's what we call a spectator ion. It just watched the reaction happen. It didn't do anything. It wasn't part of the chemical equation.
Lazy.
So guess what we do with the people that are lazy? We cross them out. Boom.
Ew.
Okay? That's a spectator ion. When you have spectator ions, you cross them out. Do you see any other spectator ions in this thing?
Yeah.
Which ones?
2 Cl minus.
Let's cross them out. Boom. Get rid of those
Damn.
spectator ions. Now, what we have written down before we cross those out was called the complete ionic equation. It contained all of the ions in solution.
Alright.
What we're going to write down next is the net ionic equation, which is just the ones that actually participated in the chemical reaction. So,
CO3 negative
CO3.
2.
CO3. I like to write the positive ones first because that's the way I roll. So what's the first one?
Calcium.
Calcium 2 plus and
CO3.
CO3 2 minus. And what did it form? The only thing left.
CO3.
CaCO3. Right there, and it's a solid. Boom. Do you see how this has the ions in it?
Uh-huh.
But only the ones that participated in the chemical reaction, not the spectator ions.
They just smushed together.
Yes, that's what's called a net ionic equation.
Cool. Goodbye.